Alright, today we're going to talk about parallel and perpendicular lines. Parallel lines never intersect, and they never intersect because their slopes are the same. Perpendicular lines intersect to form right angles, and they form these right angles because their slopes are opposite and reciprocals. This means they have opposite signs and they're flipped. So, for example, if I have a slope that's 1/3, the perpendicular slope will be -3. When you flip 1/3, it becomes 3/1, and then we change the sign. So these are examples of lines that will be perpendicular based upon their slope. Now, if you remember from middle school, to find the slope given 2 points, we use the slope formula. And I think we've actually talked about this earlier in the year. But your slope formula is m equals y2 minus y1 divided by x2 minus x1. And your ordered pairs are written in the form of x1, y1 and x2, y2. And this is nothing new because we've used this x sub 1 and y sub 1, x sub 2 and y sub 2 when we were using the distance formula. All right, now as a review, to find the slope of an equation. So I'm not given 2 points. I'm not given a line. All they're going to give me is an equation. So when I have an equation to find the slope, we're going to solve for y, and the slope is the coefficient of x. So in the equation, 2x plus 3y equals 9. You're going to start by subtracting 2x from both sides, and you get 3y equals -2x plus 9. Then you're going to divide by 3, and you get y equals -2/3 x plus 3. So for this particular equation, the slope is -2/3 because that is the coefficient of your x. So if we were looking for an equation whose line is parallel, we would use -2/3 for the slope. If we wanted to find an equation whose line was perpendicular to this equation, then the perpendicular slope would be, you're going to flip it, that will make it 3/2, and you change the sign. So positive 3/2 would be the perpendicular slope. Okay, now we're going to learn how to write some equations based upon some given information. Okay, so we have an equation here that we need to learn. I'm not sure if this is going to be on your EOCT formula sheet or not, but for right now, we'll just say learn it. And then once I check the formula sheet, if it's there, then I'll let you know, and we won't have to worry about wasting memory space. So this is called point-slope form. This is your point-slope form equation. In order to use this equation, there's 2 things that we must know. You must have a point, which is given to you as an ordered pair in the form of x1, y1. And you must have a slope, and keep in mind that the letter that represents slope is always m. So if we have a point and a slope, then we can use this point-slope form equation. It's read y subtract y1 equals m times x minus x1. y1 is the y-coordinate from the point. M is the slope. x1 is the x-coordinate from the point. This y and this x has to always be part of the equation. So here's an example that we're going to use. And it says line P represents the equation 2y plus 2 equals 6x. Our job is to find the line N, a line that is parallel to line P and that passes through the point 6, 2. So we're going to start out with the equation that we're given for line P. And we have 2y plus 2 equals 6x. The problem talks about finding an equation that is parallel. Parallel means the same slope. So to find the slope of this equation, I need to subtract 2. I get 2y equals 6x minus 2. Then we're going to divide each term by 2. And y equals 3x minus 1. So for this equation, your slope is going to be 3. We know that the slope is 3 because 3 is the coefficient of x. Since the problem asks for a parallel equation, we're going to keep the slope as m equals 3. So now I'm going to use m equals 3, and they want the line to pass through the point 6, 2. So here's your x1 and your y1. And I'm going to use my point slope form, y minus y1 equals m times x minus x1. This is going to be y minus 2 equals 3 times x minus 6. And now we're going to put this equation in slope-intercept form. We're going to first use distributive property, and you get 3x minus 18. We're going to add 2 to both sides, and I have y equals 3x minus 16. So here's my new equation that is parallel to this equation and passes through the point 6, 2. So if we were to graph these two equations here, because the slopes are the same, these two lines will be parallel. This one will have a y-intercept of -1. This one has a y-intercept of -16. So remember, parallel lines have the same slope. So now, let's look at an example that talks about perpendicular equations. So we're going to use line P again that has that equation 2y plus 2 equals 6x. And we're going to find the line Q, a line that is perpendicular to line P and that passes through the point 6, 2. So now instead of parallel, we're focusing on perpendicular. That's the only thing we changed about the problem. Everything else reads the same. We're going to start with 2y plus 2 equals 6x. We're going to subtract 2 from both sides. 2y equals 6x minus 2. And we're going to divide by 2. And we're back to that same equation. Y equals 3x minus 1. So in this equation, m, which is my slope, is 3. But since I need a perpendicular equation, then we need to talk about the perpendicular slope. With a perpendicular slope, we have to flip it. So if this is 3 over 1, then it flips and becomes 1 over 3. And then the signs have to be opposite. Since this is a positive 3, this slope has to be a negative. So my perpendicular slope would be -1/3. Okay, so we're going to use perpendicular slope, which is -1/3. And we're going to use that point 6, 2. That's your x1 and your y1. We're going to use the same point slope, y minus y1 equals m times x minus x1. And you're going to have y minus 2 equals -1/3 times x minus 6. Y minus 2 equals, use your distributive property, -1/3 x plus 2. Add 2 to both sides, and you get y equals -1/3 x plus 4. So this would be the equation that would represent line Q. And line Q is perpendicular to line P, and we know they're perpendicular because if you look at your slope, this slope is 3, and this slope is a -1/3. They're opposite reciprocals. So if you were to graph these two equations on the same coordinate plane, these lines will intersect to form right angles. So to review parallel and perpendicular, parallel lines never intersect, they have the same slope. Perpendicular lines intersect to form right angles, and their slopes are opposite reciprocals. To find the slope given 2 points, you use the slope formula, which is m equals y2 minus y1 over x2 minus x1. To find the slope of an equation, you put the equation in slope-intercept form, which means you're solving for y. And if we have a point and a slope, we can write an equation in point-slope form by using y minus y sub 1 equals m times x minus x sub 1.